Here we have a question about exponential graphs. What I've gone ahead and provided here is 4 different shapes of the exponential graph when you tweak it with some negative numbers. So for instance, here's your standard exponential graph, a to the x. But if you replace that x by a negative x, you flip it over the y-axis like this. Or if you put a negative in front of the exponential rather than in front of the x, you flip it over the x-axis. And if you do both, you actually get reflection over the x-axis and over the y-axis. So we're going to use this to our knowledge to help us solve this problem. Now you'll notice that there's no negative in front of this expression, nor is there a negative in front of this expression. But maybe sometime down the line you will see a negative in front of the x there or in front of the 2, which in that case you'll need to figure out what the reflection is going to be. Here though, there isn't too much that's happening. All we have is a rightward shift of 1 unit. So this is right by 1 unit. And this is a shift down by 3 units. So numbers that occur off the exponent, that is off to the side, those will cause a vertical shift, whereas numbers that are tucked in with the x inside the exponent, those cause a rightward or a leftward shift. Bear in mind that you might think that a negative would go left, but turns out negative up here goes to the right. This is a little bit more like we'd expect it for values of x that are or values of any constant that's off to the side, like this -3, minus goes down, plus goes up. But here, this minus actually shifts us to the right rather than to the left. All right, now with that in mind, we can figure out what this is going to look like. So let's start with just y equals 2 to the x. So here's y equals 2 to the x, a real quick sketch. Every exponential graph, at least the standard a to the x, passes through 0, 1, and has a horizontal asymptote of y equals 0. This is true of this graph no matter what the exponent is. It could be 2 to the x, 3 to the x, and e to the x, infinity, a million to the x. Any value of a that you put there will give us that will give us that shape. It will always have this y-intercept and this asymptote. But as we said, there's a rightward shift of 1 unit, and there's also a downward shift of 3 units. So what ends up happening is this horizontal asymptote that we know to come to expect sits here at y equals 0 is going to shift down units, now down to y equals -3. Furthermore, we shouldn't really expect this dot, or this coordinate 0, 1 to still be here because it is going to get shifted down 3 units, sure, but then there's still that rightward by 1 unit shift. So we don't really, it's probably going to be there, that's fine. We're just going to kind of eyeball it here, and there's our exponential graphs. Now, if you're not satisfied by this, or you don't feel like it's kind of hard to pick out an answer choice among some answer choices, one of the best things to do is to plug in a really easy x value to figure out and see if it passes through one of the graphs given. So for instance, I'm going to pick x equals 0. This is a really nice number, a really easy number to plug in. And let's see what happens when I plug it in. If I plug in 0, I get 0 minus 1. Actually, I'll just write this out in orange. I get 2 to the 0 minus 1 is -1 minus 3. 2 to the -1 is better known as 1/2, or we'll say 0.5. And then -3 is -2.5. So if you're looking at a graph, you should expect 0, -2.5 to be on that graph. Now, if we have tick marks here, here's 1, here's 2, here's 3, there is about -2.5. So I can be fairly confident that this is the graph without having to do much more work. And that's all there is to it.